demo looking at a few salts and their pH so we could work out what species are actually in solution. The first one we're looking at here is ammonium chloride, which is slightly acidic. I actually expect it to be more down near the 4 to 5 range rather than 6, but as you can see below, you can write a reaction to show one of those two ions, ammonium, reacting with water or hydrolyzing, increasing the concentration of hydronium ions, and it's this increase of hydronium ions that leads to a pH less than 7. Our second one was NaH2PO4, so sodium hydrogen dihydrogen phosphate, and dihydrogen phosphate is a thing we call amphiprotic. It can react with water to be a base, as you can see by the first equation, or it can react with water to be an acid. The only way we know which one is actually happening more often, because they're both happening, which one's more prevalent, I suppose, is by doing a reaction or a test with an indicator. The indicator has shown that it's acidic, which means that the second reaction is happening more to completion than the first reaction. So when it hydrolyzes, it makes hydronium more than it makes hydroxide. The next one we looked at was sodium hydrogen carbonate, another amphiprotic anion. The hydrogen carbonate can act as an acid or a base, so accept or donate protons, or H+. Again, we used an indicator and saw that it was alkaline, so that tells us that its alkaline reaction happens more readily than its acid reaction. So in water, you have some hydrogen carbonate turning into HCO3, H2CO3 and hydroxide more often than you have it turning into carbonate and hydronium. So the hydroxide ion concentration is higher than hydronium. The next one, which probably we should have done before that one, was sodium carbonate, which has an even higher pH. And that's because, although it's very similar to hydrogen carbonate, it doesn't have the hydrogen ion to be lost, so act as an acid. So its only possible reaction is to be a base. So we see that it's actually got a pH around about 10 or 11 in this case. Our last one we were trying to decide if it's a trick question or not, was sodium sulfate. So we wrote down sulfite reacting to form hydroxide ions, but then when we tested it, the colour is very, very close to 7. So either it doesn't dissociate much at all, so the hydroxide ion concentration is hardly changed at all, or it is indeed neutral. We've made an assumption that that colour is so close to 7 that actually this just dissolves and doesn't dissociate with water or hydrolyze at all. We'd need to check that with a quick search on Google or something like that, but we're pretty confident that that one just dissociates, unlike the other 4 that we looked at in this experiment.